is household socket and extension cord. And second one is domestic socket with protection device. And third one is specific socket on dedicated circuit. And fourth one is direct current connection for fast charging. Coming to first one, that is household socket and extension cord. In this mode one, you can see here, that is mode one charging mode. In mode one charging, an extra wire is used to take electricity to a piece of electrical equipment when it is an extra distance from the nearest socket. That is used for mode. That is used in mode one charging, and this mode is used as home charging with a simple extension cord, and the socket outlet doesn't exceed 16 amps and 250 volts. It doesn't exceed 16 amps of current. Uh, uh, if it beyond 16 amps, it is some cases it may be failure. In some countries, mode one charging is outdated. It is outdated in some countries. That's why we can go for mode two. Coming to this mode two, this is here domestic socket with protection device. Here we can observe in this picture a controller is there. This controller is used to use safety purpose. This mode is generally used in homes but with special in cable EVSC. And coming to second point, in this mode socket is firstly connected with EVSC, then transferred to electrical vehicle. In this socket, first we connected to electrical vehicle supply equipment, then transferred to electrical vehicle. Coming to third point, the power transfer to the vehicle doesn't exceed 32 amps. Here, mode one charging, uh, there is 16 amps only appear. 16 amps only, that is limiting point, and this mode 2 is 32 amps. This is uh, some more better than mode 1, and in AC single phase is enough. Next, mode 3 charging. Mode 3 charging is, that is specific socket on dedicated circuits. As we know that what is dedicated circuit? A dedicated circuit has its own circuit breaker, and it is only supports one outlet. Here circuit breaker is there, and if any fault occur, we can use circuit breaker means if any faults occur, circuit breaker gives a signal to the in electrical vehicle. That's why you can use circuit breaker. And first point is in mode 3, the vehicle is connected directly to the electrical network through specific socket and plug, and then a dedicated circuit attached. Here we can observe electrical car is there and charger control is there. Between that, a socket and plug and dedicated circuit is attached, and it consists of some protection, and it consists of controlling management is also there, and it is installed in the installation. And coming to mode 4 charging, the electrical vehicle is connected to the main power grid. Coming to this picture, you can observe here, there is no any mediator between this AC DC and electrical vehicle. That is, charging is wide in DC charging station installed mainly in public places, and this can be, there is no any, by using cable we can directly connect between AC DC supply to electrical vehicle. That is mode 4 charging. And coming to our third agenda, innovative business models in India. In India and in any countries, there is a huge sponsors is there to give money or give money and support to the EVSC investors. Coming to this first point, innovative business model to incentivize the EVSC investors and government and municipality inventions with respect to concessional allotment of land and other shops are required. Government gives some land either free or based on some subsidy, and they give money to the investors. Uh, that's the innovative business, and some of the suggestions are listed below. Electrical wholesalers and retailers may be mandated to set up EVSC network in strategic locations. government also support and the state governments also support to give money to the EVSC investors. And second point is state government to allot space for EVSC networks on long lease at a concessional or free. That is innovative business models in India. It is entirely increase the growth of country because if we use electrical vehicles, there is no need to use fuel like petrol, diesel, and kerosene, whatever it may be. Uh, it gives and it is also pollution free. That's why we can go here electrical vehicles. And my conclusion is as we discussed, as I said in this paper, there are different EV charging methods that are as I said, one is conductive or inductive charging. In conductive, a cable is connection between them. In inductive charging, a direct electromagnetic field is between them. And coming to next, as I discussed, models, there are four models. And finally, innovative business models and their charging infrastructure. That's all about this paper. Thank you, sir, for giving me this opportunity.
Well, Munindran. Okay, Munindran.
Yes, sir.
So you know that aware of that inductive charging.
Yes, sir.
In that inductive charging, they are using the electromagnetic
Yes, sir.
conversions are taken places, right?
Yes, sir.
That means there is some frequencies are involved in that while converting, right?
Yes, sir.
That frequencies are decided by how the frequencies are generated there.
Sir, in inductive charging, sir.
For transmitting coiling and inductive coil, how the energy will be transferred? The energy will be transferred from primary coil to secondary coil, that is transmission coil to receiver coil, right? So here, while transferring the signal from primary to second, that transmitter coil to receiver coil, it's converted in transmitter coil means it converted some frequency, it's generating some frequency, right?
Yes,
That
sir.
frequency only transfer to received coil, right?
Yes, sir.
Okay, how to create that those frequency in that coil?
Sir, electromagnetic induction, by using electromagnetic induction.
Electromagnetic induction is nothing but it is you can mention as a electromagnetic induction is nothing but it's generally you can name it as a voltage or potential difference or an applied force and magnitude you may given different names.
Yes,
But
sir.
here frequency is involved, na?
Yes, sir.
That frequency how you decide? Then how the frequencies are generated in this section?
Sir, by using single phase AC supply.
Single phase AC supply. How much? How much? What is the rating of single phase AC supply? Basically,
220 volts.
two
20 volts.
220 volt. What is the frequency?
50 hertz.
Okay. In our Indian country, you are given it's a
50
50
hertz.
hertz, right?
Yes,
Okay. Now you are from that head. If you go for inductive charging, how that 50 volt will be transferred to the that transmitter side? In between, what process will be taken places?
Sorry, sir. I have.
Not
Sir,
aware in that.
by using transformers.
Transformer is used to step up and step down the voltage level, right?
Yes, sir.
Without changing the frequency, it step up and step down.
Yes, sir.
That means the frequency never change in transformer. Then how the frequency will be adjusted there? Because yesterday your friend circles have they present some presentation 10 to 150 hertz kilohertz mentioned the section.
Yes, sir.
I think you are also watched those presentation of yesterday, right?
Yes, sir.
Because you are in the point of clarity. Because for this purpose only this conference is going on, because all the students are simply they are giving a concept only, not they are having any practical idea in the section. They are not trained also. So for that only, for the clarification only, I mentioned these points to you here, right?
Sure, sir. I will.
Mm. How it is possible? Any idea? Okay, later on you will check it out and tell, right?
Yes.
If time permits. Okay. Okay. Thank you, Munindran.
Thank you, sir.
So
Any
any more questions from the participants?
Yeah, sir. Munindra, how you are decreasing the charging time for EV?
decreasing charging time.
Yeah. How you are decreasing that charging time?
We're not decreasing the charging time. I mean, by using, wait, I will explain. Here, EV charging levels is there. There are three levels of charging. We can increase the time. I mean, if we charge 1 hour of charging to the that electrical vehicle, we can increase the mile. We can increase miles, not charging.
Yeah, I am asking how to decrease the charging time. That's what I am asking. It's important, to decrease the charging time.
Okay, by using 50 kilowatts rapid charger. I mean, high amount of wattage charger we can use. The on the time it will be less amount of take time.
Okay, any more questions from other participants? Manindra, I have a question for you. Go to the slide number 1. You said charging of EV, charging an EV cheaper than buying gas. Now, what is per kilometer charge if you go for this EV vehicle?
Per kilometer charge, sir.
What will be the price? As you said, EV is definitely cheaper than the other conventional methods. Now, what is per kilometer charge? Now, how much will that be?
Sir, rupees 1.2, 1.4 per kilometer.
Now, what is the difference?
Sir, coming to by using gas, it will be more cost, sir, compared to electricity.
Uh, you're just giving a statement. What my question is, what is the difference? Now, when you say it is cheaper,
Yes, sir.
definitely one has to.
Running cost, sir.
Okay, fine. Thank you so much. Now you may close your presentation. I request NCVI 010 Vinay and company to get ready and present their presentation. Please share your screen.
Yeah, good morning, sir.
Good morning, Vinay.
Uh, can you please confirm anyone so that my screen is visible to you all?
Yes, it is visible. Put the screen over this no? Full screen.
Yeah, sure, sir.
Now it is very clear. You may go on.
Yeah, thanks, sir. Thanks for confirming. So before presenting, let me wish heartily congratulations to my college, Chaitanya Bharat Institute of Technology, for handovering the session AICT sponsored National Conference on Electrical Vehicle Charging Infrastructure. It's very good to me to have again here as a alumni, and with extending warm greetings once again, Chief Patron Dr. V. Jayachandra Reddy Garu and Patron Dr. G. Srinivasa Reddy Garu, and Head of the Department Dr. S. Suryaprabha Garu, Convener Dr. R. Sarvanam, Co-Convener Mr. N. Varaprasad, and my beloved faculty members there, my Gurujis and mentors, and my fellow juniors, all everyone, and today's panelist Dr. K. Kadiravan Sir Garu, and everyone a warm welcome and very good morning. Hope everyone is doing good.
Yeah, good morning, very good morning. We'll start your presentation. Yeah.
Yeah, thanks, sir. So I'm myself Vinay. I'm working in Infosys as a test engineer. I am presenting this presentation along with my associate professor, Mr. N. Varaprasad Sir Garu, and Vishnuvardhan Reddy Sir Garu, assistant professor, Department of Publicity IT. So my today's presentation is a simple review, that is a recapitulation on electrical vehicle DC charging station employing photovoltaic sources. So let me brief up about the contents today's of this presentation. So we'll go with first identification of problem, abstract, then existing system, So existing system in the sense, what are the previous researches is going on and also was there under literature review, and a brief about electrical vehicle charging standards and photovoltaic charging topologies as well, and different type of hardware infrastructure in PVCs, and we will conclude with this presentation after the contents is over. So before diving into problem identification, there is a huge demand for electrical vehicles nowadays. And also we have seen different kind of companies they have been starting up with their electrical vehicles. And recently Tata is also launched Tata Venue, as we know that uh, electrical vehicles in part of automobile industry. So, and government of India has also declared public charging stations and also EV charging business as a delicensed activity. That is, there is no license for to have this for now because it is still growing on. So, based on this statics, like there should be proposed one in metropolitan cities or highways. There is expected at least one charging station for every 25 kilometers, especially in highways, that to metropolitan states. So this coverage to be achieved in cities with a population of more than 4 million and all existing express highways and also important highways. So moving forward, there are many companies like Tata Power, Fortune, and other which are engaged in the business of electrical vehicle charging. So in this regard, there is a charging infrastructure mainly setting up of level 2 charging at public uh, level. So level 2 charging, since I think one of our friend has previously covered a different type of levels in charging. So there could be potential important for charging stations compared with parallelly electrical vehicles. So for normal charging, the charging time poses a serious problem as it ranges from 6 to 8 hours. Whereas for fast DC charging, cost and renewable energy sources are the biggest factors which could pose a problem. So these are the main problem identifications. So and also government are also giving some substitutions to install the charging station in express highways, and also different companies we have seen that uh, installing the importance, highlighting the importance of charging stations. So this could be our problem statement and also problem identification. So we have conducted a small review. So which if you are employing photovoltaic sources, what is the behavior with the integration, and also different kind of systems like MPPT technique, and what if happen if we are using ECS like that. A simple review kind of paper it is. So the abstract, coming to the abstract, we are highlighting the importance of charging infrastructure that has to be designed in such a way that to meet huge growing demand of whatever industry you take, automobile or fast charging vehicles that you tramways, especially in foreign like that. So there is a huge demand for and also huge potential importance for charging infrastructure. So there are the reports that studies that include charging standards, the power converter topologies that focus on the adoption of vehicle to grid V2G technology especially, and the control of both PV grid and PV standalone DC charging stations. And in this abstract, we are showcasing the different type of topologies as well. What will happen if PV grid charging system and standalone PV system. So there is nothing different. If we are integrating all the PV array with DC bus, then we can say that we grid in the sense interconnection of different systems, and standalone PV in the sense by using PV we are giving to ECS, that is energy storage system. There it will be divert to DC bus. Then the other precedence dependencies go as like it. So, and from a practical point of view, also distinction between two architecture is the bidirectional inverter, which means it can, according to the situation, it can convert to DC into AC, and also vice versa is also possible. So this is what kind of abstract we are proposing, and DC-DC converter we provided with MPPT control, a simple brief about that, and energy storage unit ESU, and bidirectional DC charger and inverter. So if you took previous research like literature review, there are previously the research is going on like charging station sized based on the average power demand, and they have used pulse diode rectifier is justified to the most suitable topology for that application in their previous researches. So in this paper, we are going with a bidirectional inverter, and also charging stations photovoltaic assisted attracting a substantial interest due to increased environmental awareness. So if we are using too much of industrial materials like different kind of any emitting resources like that, then that also we considering in mind, and that's what we're proposing PV, a brief review PV array on the brief review on that. So cost reduction and efficiency of the PV modules are also stated in this presentation. So we can see that some references are listed below. So for the previous research that literature review is going on. So before let me brief about electrical vehicle charging standards. Some of the friends are already covered. So the level one, level two, level three. That means the different levels are categorized under main three levels. So that is from Society of Automotive Energy (SAE). So they are working on the standard J1772. So based on current and power, they have been developed. If the current rating is 80 amperes and the maximum power can be 40 kilowatts, and similarly for level 2, the maximum current of 200 amperes with respect to the power of 90 kilowatts. And level 3 is a fast charging mode where DC voltage directly to the battery via DC connector with a maximum power of 240 kilowatts. So these are brief about level 1, level 2, level 3 electrical vehicle charging standards according to the SAE. So the box also consolidated in a simple terms of EC standard as well and Tesla motor. So different type of classifications is there, but we mostly prefer SAE standard in our India level. So in the box we can see the different type of levels and maximum current rating with respect to manpower rating. So moving forward, then we will talk with the photovoltaic charging station topology. So if we are looking topology, we have only mainly two categories. That is PV grid charging system and PV standalone charging system. The name itself represents PV grid charging system. It is the interconnection of PV, and we can include that ECS also, energy storage system, that is ESU. We can also include according to the load disturbances. For example, if the load demands suddenly high power, then PV array doesn't able to provide within short time. That is nothing but ramp rate. Within short time, PV array alone itself it won't provide. So for that uh, there is some a diagram is also posted. Let me open laser pointer here. So if we take the block diagram of PV grid charging system, we can see that is a energy storage unit here, and the PV is also connected to the DC bus. If you remove ESU, then if load required any additional loads, that I mean, if it requires maximum loads at a peak hour, then PV array doesn't able to provide. So that time we are not always depend on solar irradiance on that. So that we are integrating with the ESU. ESU is nothing but energy storage unit where it can deliver the power according to the load with high density rating. So that's what the other dependence loads, that is output loads, can be I mean compensated with the ESUs. So this is a PV grid charging system in brief about. And also recent technologies we can integrate with electrical vehicle charging system, and this is we can see that uh, normal AC lines we have saving. So whatever based on bidirectional inverter we can achieve this. So this is nothing but a PV grid charging system. And if you look next one, PV standalone charging system. If you look the standalone system, we can say that PVR is not connected. Instead of PVR is not connected to the bus, it is connected to the ESU. That means the power is delivered to ESU first, that is energy storage unit. Then through the ESU, it is delivered to DC bus. So we can see that. So the first PVR is giving power to the ESU, where from the ESU the power is delivered to the DC bus. So then after that, the power has been transferred to according to the grids or whatever required. So in this paper, since charging infrastructure, we are focusing on charging the infrastructure vehicles. So this is two type of topologies we have. One is the grid system and standalone charging system. Now there is a hardware infrastructure in PVCS, and PV system can be activated with MPPT control, maximum power point tracking. So maximum power point tracking is nothing but, let's say, we know all familiar with sunflower plants. Whenever the sun rises east, it will automatically turn. It's a natural behavior of the plant. Similarly, in this MPPT technique, maximum power point tracking. So if you are facing our PV array to directly to the sun, we can get more amount of power rather than deciding a shadow or any other condition. So in this technique, uh, we are derivating power with respect to time. For example, if P2 is power, that is dp2 by t1 with a to time. If dp, that is differentiation of power, greater than 0, then that means what will happen, there is a still there is a scope for to increase the tracking angle with respect to PV array. Then again power is increased by changing the direction of PV array. Then we will calculate P1 and P2. Again we will differentiate dp. If dp output dp greater than 0, what will happen, there is a scope for to increase much more. Similarly, we reach this point some greater extent at peak point. So after reaching this peak point, we will correct. Again, we will found much more scope in this. That is dp greater than 0, and we will move forward with P2 direction. That means PVR is tracking to other direction. So there itself, we will calculate power P2 with respect to again P1. Then we can say the difference is negative. That is dp less than 0. Then there is a less source compared to previous one angle. Then we will align previous angle of the PV array. So by these to and fro motions, by adjusting the the PV array, we can able to figure it out maximum point. That is nothing but MPPT control, maximum power point technique, or maximum power point tracking also fine. So it's nothing but to identify operating point at maximum power point. So once if it is a maximum power point, absolutely the power is more, and the usage of that particular energy is also good. So that's what. Similarly, we can characterize the curves with IV and PV as well. So the main important of the MPPT technique is we are deriving power with respect to time. If it is less than 0, then there is a scope and we will change the angle. Then we can with the technique we can find out one maximum power point, that is operating point of that PV. So there we can obtain much power. Okay, so we can also go with duty cycle as well. If the power is required low on high and low according to the output, then we can easily modify according to the duty cycle of PWM control. So this is in detail about the this point is about in detail about duty cycle. So this is a simple point we put. If we want, we can use duty cycle also, but in this paper we are going with MPPT technical. So, and one more important aspect in hardware infrastructure is bidirectional inverter. We are all very familiar about bidirectional inverter. So it's nothing but it can convert DC to AC, and nothing but inverter operation. When it will be operate inverter operation, when AC loads are depending from the output side. That it means what? It will take DC as an input, then convert and give to AC. So similarly, what will happen if ESU, that is low power, then ESU itself required power. Then at that time we will take AC power from grids, AC grid. Then our bidirectional inverter will act as a watt converter. That means AC to DC. Then it will store. So this is the how way the bidirectional inverter works. So it will act as inverter mode and rectified mode, vice versa. And this is the additional equipment we can integrate with the infrastructure, that is energy storage system. It is nothing but the main intention of the ESV is to provide the power with high density. I mean, power high density in the sense high density. We can send the maximum current within short time. That is nothing but ramp rate. So there is a few techniques also is there in ESU, and the researchers researches is also going on magnetic superconductivity, SME, that is magnetic superconductivity coil. So uh, based on by decreasing resistance zero, they are achieving what, zero resistance. Then if the zero resistance is achieved, then superconductivity property is achieved. Okay, that is another side of research. But so this is HES, hybrid energy source system. So hybrid energy storage system is nothing but they are using flywheels and supercapacitors. Okay, this is the future scope of this ECS. But a simple ECS is a simple storage system. It will send maximum current to the loads whenever required. Loads in the sense it can send to bus, thereby through bus it will send to loads. So this is nothing but energy storage system, and it is integrated with the grid. So it required the power is taken with high current density. Nothing but it is a ramp rate, kilowatt per with respect to time. And energy management system is nothing but it's a kind of control we are managing. There is a control line will be there, and in this paper there is a we are using wireless Zigbee communication just to track the parameters of the um, like voltage, current, what are the parameters. And for example, SCADA control is also there. I'm talking about other side of this paper. So in SCADA control, there is a control signals is also there. There by that SCADA, they are achieving uh, energy management. Similarly, here also we can achieve energy management system by using CAN, that is communication area network. It's nothing but normal routing and networks, so that we can able to figure it out what is the power is delivered and what is the parameters of with respect to time period. So that's what energy management system is comes in. I think this is in brief about electrical vehicle charging infrastructure. Recapping that, we have covered levels of, I mean, different type of charging levels in DC, level 1, level 2, level 3, and we have seen the different type of topologies, and we have seen the materials, that mean, I mean, hardware we are using for charging infrastructure. One is ESU, energy storage unit. If we require, we can use, and if it is required more, we can integrate with HES, that is hybrid energy storage system, with flywheels and super capacitors. That is further research purpose for ESU. And we are using bidirectional inverter as well to convert according to the customer loads or load demands according to that. So finally, conclusion, we can see that PV to EV chargers that adopt V2 technology, that is vehicle to grid. So similarly, we can integrate with vehicle technology, I mean, vehicle to grid technology, and will receive an increased attention and more investments from grid operators and car makers in the future. So similarly, this concept is being there in our electricity market. There are different research is also going on. If the electrical charging station is integrated with the grid, then uh, we can get some subsidies as well, different type of uh, financial benefits as well according to the their purpose. I mean, whatever they're using, their purpose, and according to the current market, we will get some different type of benefits as well. Because we are sending not only, I mean, we are not only taking from grid, but we are sending to the grid as well if we are not required. So that's what we can also save the power whenever we're not required. So as a conclusion, the photovoltaic charging structure is becoming more complex with several functions integrated the system, which require intelligent controls in each block and real-time management for the old station. So this is very important aspect. And as a conclusion, what so once we are integrating the photovoltaic charging station, so there is a huge controls is required according to the mm, paper review. So that's what the conclusion is. And photovoltaic, the main agenda of using photovoltaic is to reduce somewhat economical factors, setting economical factors, and compared to different technologies, this is also one important technologies. And MPPT technique, that is maximum power point tracking, is also going on. So this is a simple one, and we have seen in our areas there is a large solar panels as well. So we can also integrate with the simple one, and there is a probably useful for youngsters in India to establish entrepreneurship and make it digital India as well. and there is a industry associations as well, and mobility solution providers also is there, different type of partners. And in Bangalore, there is a lithium technology launched fully with electrical taxi for corporates. So like this, there are different type of importance of in this area is going on, and also benefits of electrical vehicles we already know. On our one of our friends has already covered, and there is a subsequent government policies also involved in this. Central government policy. So they're using $1.4 billion for buyers to imposing a hike on import tariffs, and also different type of tariffs is also going on, and faster adaptation and manufacturing of hybrid and electrical vehicles, that is FAIL, is also going on. So with this, I would like to conclude, and I will go for Q&A session. If anything you have, please feel to ask. And I would like to thank to my fellow juniors there, and all our faculty members, Swam sir, Gaushya madam, Pramod Reddy sir, and Varaprasad sir garu, Vishnuvardhan Reddy sir garu, everyone in the college. Thank you very much, and we will proceed with any queries Q&A section.
Nice presentation, Vinay. Vinay, have you simulated any model regarding this setup?
No, sir. Actually, not simulated any model, sir.
Okay.
Just we are presenting with a simple review. So what will happen if we are using the PDA,
Okay.
and what is the important aspects of that?
Okay. Have you aware of that MPPT?
Yes, sir. Briefly, I know about MPPT technique.
Uh,
So it's nothing but lacking maximum power point, but nothing but we are tracking solar irradiance at operating point, maximum power point. For
okay.
example, in the PVA,
Okay.
yeah,
What are the
this,
basic types will be there in that session in this MPPT?
I mean, basic
Types of
about
MPPT techniques. Conventional.
no idea, sir. Sorry, but no, that
Not
thing
having
not
any
aware.
idea.
No.
Okay. Okay. You are telling that the solar panel will be adjustable or non-adjustable panel.
Uh,
You are telling that.
so it's a adjustable possible, sir. It's
Okay.
a
Right.
we
One
can
second.
adjust.
Okay, okay. If it is adjustable, have you locate a PV panel in that geographical position?
So, for example, let's take in a mountain area or in a solar roof, we can accommodate with the
I'm asking that that four directions are there: east, west, north, and south, right?
yeah, yes, sir.
For adjusting panel type, PV type panel means how you erect that panel, panel setup in that geographical location, in which side it will face.
Uh, it will face to east side, sir. Whenever sun direction is there, it will face to
Hmm.
east side. Then,
Okay,
if it is moving according to the sun direction, we are
okay.
tracking operating point there. Then,
Hmm.
accordingly, we can also adjust the position according to the sunset.
Okay, if it is a fixed PV panel means how you can locate in the geographical area.
If it is a fixed panel, in the sense we can able to locate, then I mean, if we are it is a fixed panel, then we cannot able to change the direction according to cell, but we can fix into one position. We can take into one at 45 degrees angle to the east. That it means
Actually,
it
fixed
can,
panel means you can face it as north to south. Okay,
North
so
to
if it is
south.
yes,
North direction.
okay, if it is adjustable means east to west. Okay, then the 10 degrees are needed for fixed panel, right? Okay,
yeah,
anyway, you are presenting very well because I think you are from third year or second year, final year.
yeah. Actually, I'm an alumni of this college.
Alumni.
Yes.
Okay, right. Okay. Okay, anyway.
Passed out candidate, sir.
Fine. Okay, sir, fine. Okay, now recently you are giving a reference of 2010 only, but latestly the many papers are came regarding this one. Now the hybrid concepts also came there, right?
Yeah.
That is fuel cell, then solar PV, then wind.
Hydrogen.
All will be interconnected with this grid along that works will going on with many optimization technique. That is artificial intelligence techniques also implemented in the MPPT. Likewise, I think recently 2022 grasshopper algorithm. I think they provide for that. I think So many advancements are came. So you have to go with that, right?
Yes, sir.
Okay. Anyway, nice presentation, Vinay. Thank you.
Thank you so much, sir.
Yeah.
Yeah. Thank you all. Thanks for coordinating.
No,
Thank you, sir.
thank you. Thank you. Okay, fine.
Yeah, okay. So we'll start with the next presentation by Dandu Maulika and C. Venkatesh. Are you ready?
Yes, sir.
Please start sharing your screen.
Is my screen is visible, sir? Hello?
Yes, yes, it is visible. Please go on.
Yeah, present.
Maulika, are there? Maulika,
I think the voice are not receiving.
Maulika, unmute yourself.
Sir?
Yeah.
Now
Now
I'm
you are
audible,
audible.
sir.
Put it on full screen. Okay. Now carry on.
Sorry, sir. So, good morning, sir. I'm Maulika. I'm from Kids College. So, nowadays, with the vast development of electrical vehicle and renewable energy sources like solar panels and fuel cells, so boosting type inverters plays a key role in low voltage application where DC source low voltage need to be boosted. So, therefore, to drive a motor, high AC voltage are required. So, but by using these and operating in high switching frequency results in more switching losses and serious EMI problems may occur. So to overcome that, this multi-level inverter with self-balanced switcher capacitor has been used. So these are the contents which I have taken. So coming to my abstract, so by using this switcher capacitor multi-level inverter, it enhances a boosting capability for low voltage application with a single DC source. So each phase is involved in two capacitors, two transistors, and so except the high voltage transistor, all the other components is fed to the DC input with phase dispersion pulse with modulation. So the two types of transistors are very beneficial for reducing low and high switching losses and selecting the semiconductor switches. So this is my introduction. So as I have said that the main advantage is to reduce the old switching stress, and the output is almost a nearly sinusoidal waveform in operation with a low switching frequency. So it is to this switcher capacitor multi-level inverter is developed to convert a single DC source low voltage to a three-phase high voltage with a four-level per phase. So capacitor voltage ripples and harmonic output voltage is reduced and switching loss also reduced. So this is my literature survey, sir, which I have gone through. So my object is to design and simulate the switching capacitor multi-level inverter with a self-balanced capacitor and to test the performance of switcher capacitor multi-level inverter based on phase disposition control for various modulation index. So coming to my circuit diagram, so if you see here, figure A, so where the switches SX and T-X is turned on when other two switches, this TX and S-X is in the off condition. So the output level is a 0.5 ADC. It's directly proved to this C1. And through the diode D-X and the switches is the SX. So the same output level can be provided by reverse series connection. Hence here, if we observe clearly this table, the C-X is in C-X and C2 for the inductive load in this state. So C-X is charged by DC source, while other CX will be in the idle condition. As we observe in the figure B also, here we are getting a minus 0.5 ADC. So the output level is 0.5 ADC, which is directly provided by this C2 through diode DX. And if we observe this figure C, so we are getting 1.5 ADC. and where this SX, the upper two switches, this SX and TX is turned on, and the other two switches, the below switches will be in the off condition. So the output level of will get in a 0.5 ADC is provided with this C1 and C-X, and in this state the CX is charged and the C-X is in the discharged condition. So whereas we can see in the in figure D, here we are getting in the minus 1.5 DC, that it is in the reverse direction. Here C-X is charged by DC source, where CX is discharged to the load. So as a this is my circuit diagram. So I done this with an for a three-phase with an R load, RL load, and this R load with an LC filter. So this is the phase disposition of three-phase step-up switched capacitor, multi-level inverter carrier waveform. So as my output level is in a 4-level inverter, I am generating it in a three carrier waveforms. So this is the three-phase carrier waveforms. So I have done with an R load. So when I done with an R load, I got these waveforms. So the phase voltage and current both are in phase, but whereas the total harmonic distortion of voltage and current, I'm getting more. That means it is 45% and current THD is 42%. So I should reduce it to less than 5%. So for a good response. So I have gone through for a RL load. So when I done with an RL load, I got the current was in a sinusoidal. So it is not pure sinusoidal, but it's a sinusoidal. So this is due to the capacitor absorbs the reactive power of an inductive load. There the voltage is and ripples are very limited. So I have done the FFT analysis for this. So when I done the FFT analysis, I got current THD is 6.80, that means 7% almost nearly, and voltage is 40%. So as I have said that before, by changing the modulation index, I have done the THD values. So for different modulation index, I got it is a voltage THD is 41% and the current THD is 6.80%. So it is not much good performance. So I have done gone through an LC filter. So when I used it with the LC filter, the RM, if you see, this was my output of the LC filter. So upper one is a three phases voltage waveform, and the down one is in a current waveform. So it was a three-phase. So if we observe this table, the THD values were compared to before. Here is almost less than 7%, and the RMS values are about 190 volts to 340 volts. So the output, the load voltages are sinusoidal, and there are only fewer lower harmonics. So it is benefited from the PD, that is phase disposition pulse width modulation strategy, which eliminates the main lower harmonics when the load is changed between the 100 to 200 ohms. So the ripples of a capacitor voltage is increased along with the rise of a load current, but they are very stable and balanced. That is, this is due to the self-balancing capacitor has been used. So if we see here, the voltage and the current THD is less, so compared to without using the filter. So it was in a best. So I thought it to apply for an electrical vehicle. So due to the climate. Due to climate changes and advancement in renewable energy sources, so rapid urbanization, battery technology, and EVs are becoming very popular choice. So actually, European government are planning to phase out combustion engine vehicle by 2040. So EVs with permanent magnet and BLDCs have high initial cost. So why I chose induction motor? There is a high initial cost, and this 4-level inverter is analyzing for induction motor drive in EV application, which is used to reduce the torque ripple of a motor, which will be leads to silent and smooth operation. So there is not much ripples of the vehicle. So reducing in voltage stress across the switches and the current stress also. So which will reduce the failure rate of switches, and the cost of the switches is also very less. So these are the waveforms for when I applied this multi-level inverter to a motor. If we observe in the first case, it was in a speed. the speed is getting regulated up to 1500 rpm. That means it is a good response, right? So, and it was getting very less time, that is only 5 to 6 seconds it was generating, and there is no ripples also. If we observe the second waveform, it is in the torque, and the third and fourth waveforms are voltage and the current. This blue line indicates my current, and the other one is an voltage. Here I am getting the voltage up to 420 volts, and the current is up to 5 amps. So because of low switching losses, there is no variations in the waveform. Coming to my conclusion, so these are the topology and working principle of SCMLIs are examined, and as I said before, that reducing the switching losses of operation of one switch with a low frequency, and they are very suitable for large rated motor drives, and traditional 230 volts to or 460 volts motor can be used, and higher efficiency is expected for these multi-level converter system, because high voltages can be utilized and the switching frequencies of the device is at minimum. So low voltage switching devices can be used. So by that, there is no EMI problems, and no charging unbalancing problem will also occur either in the driving mode or in the charging mode. So the main where we are going to apply these multi-level inverters means we can use in electrical vehicles and renewable energy sources. These are the references I have gone through. Thank you, sir. Thank you for giving this opportunity.
Nice presentation, Moulika. So go to that black diagram. Actually, I think you run the simulation, right?
Yes, sir.
Right. Okay. Go to the black diagram. Main black diagram. So, what type of converters here you are using?
Sir,
What type of converters you are using
it's
here?
an inverter, sir.
Inverter means that is
DC to
DC
AC.
to AC, right?
AC, yes,
Okay. Can you show that problem? This is DC to AC.
sir. Sir?
Yeah, this is an DC to AC. You convert this one, right?
Yes, sir.
Okay. Then you are using 4-level controller, right?
Yes, sir.
Okay. Okay. Go to next slide. Go to THD. THD section. Wait. Go back. For R load, go to R load. How many cycles you calculate the THD value?
For 2 cycles, sir.
Go back to our R load. Next to that slide. Wait. For 2 cycles only you are taken, right?
Yes, sir.
For 2 cycles, here you are getting 42.03 THD, right?
45%.
Voltage and current. Okay. Go for RL. So RL load. Here, how many cycles you taken?
I had taken for 1 cycle only. Sorry, for R load also I had taken for 1 cycle only, sir.
1 cycle means you are using actually inverter, right? How much frequency you are going to consider?
50 Hz frequency.
50 Hz means okay. 1 cycle means here for 1 cycle how much time you are taken here? You are considered here.
For calculating THD, sir.
Yeah,
FFT
because
analysis.
that is important. Yeah, for FFT analysis, for 1 cycle, how much time period it taken?
0.02 seconds.
0.02. Why? 1 cycle is enough to find the THD?
No, sir.
If
2
you
to 3
increase
cycles I need to.
if you increase the cycle up to 10 means surely your THD value will be more, right?
Yes, sir.
Then why not show that?
Actually, I have done for that also, sir, but I have not included.
Because that means you are showing that perfect results. Remaining results you are just off that, right?
Oh, yes, sir.
Okay. Next, go to the next section. Next one. Next slide. Okay. Right. Wait here. Here you are seeing that voltage THD will be 41 something for 1 cycle. For one cycle here, current will be 6.8, right?
Yes, sir.
Okay. What is the maximum voltage you consider here?
100 volts,
AC,
sir.
AC output voltage.
150 volts I'm getting, sir, output.
150 volt, 150 volt, 20 hertz you are fixed. This is standard for our country or which country?
50 H, sir.
50 hertz, okay, pa. That means that output voltage should be our country means it should be 230 or 230 volt, na,
Sir,
approximate.
actually for this R load and RL load, I'm getting this, sir. When I'm using it motor, I got a 420 volts.
420.
Yes, sir.
420 volt means that is nearly it will be three-phase supply, right?
Yes, sir. It is 3 phase.
Three-phase from DC. From what is the DC input?
For motor, I have taken
So,
100 volts.
for before converter, what is the input of input?
100, sir.
100
100
volt.
volts.
What's the ampere range? What's the ampere range? 100 volt, you are boosted to 420 volt, right? Here.
No, sir. For motor, I have taken motor input. For
How?
this,
That means you are separately do this simulation. Converter section you are separately alone you done the experiment. Then for motor you are alone alone you are done the experiment. Likewise you made a simulation in that section.
no, sir. For
Hmm.
motor, I have taken it 200, 150, 200 volts, sir.
200 volt.
Yes.
Have you simulate the motor for bike or car or auto?
No, sir. I have not simulated.
Then how you tell the electrical vehicle? Electrical vehicle means that is a fixed standard is there, na? Bike how much range? Volt. Then for auto how much range? Then for car how much range? There is some fixed ranges are there, na?
Yes, sir.
With the respective range only you have to simulate, na? Right?
Yes, sir.
Then why you not using the SRM motor? Because BLDC having lot of drawbacks. So now recent days many of them are using that SRM motors.
Yes, sir.
Switch reluctant motors are using for electrical drives, right?
Yes, sir. Yes, sir.
Why not you try that one? Because it is easy compared to BLDC. Then cost also somewhat better only, right? There is
Yes,
two
sir.
types. What are the types? Have you ever in that SRM motor for designing EV vehicle?
No, not thoroughly, sir. But
Okay. First of all, what is harmonics? First of all,
sir,
what is harmonics?
the harmonics is means several average of this. It means output will be in the.
What is harmonics? Simply, I am asking, what is harmonics?
So this current harmonics are AC voltage and current with frequency that are integer multiples of fundamental frequency.
The multiples of fundamental frequency, right?
Fundamental frequency, yes,
Right.
sir.
Okay. Right. So if it is a third harmonic, which here you are reducing the harmonics, na?
Yes,
Okay.
sir. Yes, sir.
Right. Reducing harmonic third. Have you reduced the third harmonic or fourth harmonic or fifth or seventh? You not mentioned those things here.
Yes, sir. I have not mentioned.
Why? Okay. Which one here you are reducing the third harmonics, even harmonics or odd harmonics? Which harmonics you are reduced here? It's audible.
Yes, sir.
Hmm.
Sorry, sir. I don't know. I go through this.
Okay. Third harmonics means basically what?
It is 180 Hz, sir.
One?
180 Hz.
180. Fundamental frequency is 50 means 3 into 50 what?
150.
Third harmonic means it's the 150.
150.
Okay. Within one cycle, that is 3 times a cycle will come there. Okay.
Okay, sir.
Before going to this one, you have to you have to clearly you have to learn the harmonics. Then what are the harmonics will be support aids, and what are the harmonics will be non-aiding to that input. That you must know that. Okay, basically all harmonics are aids. Even harmonics are aids to output.
Oh,
Odd harmonics are opposites the outputs. These things you must know.
okay, sir.
Okay, likewise, only have to design any inverter and model and anything, right?
Oh, okay.
Otherwise, you have to check some more papers. It is easy for you, right?
Okay, sir.
For your clarity only, I am mentioning these things to you, right?
Okay, sir.
In
Sure, sir.
in future, you have to go according to this, right?
Okay, sir.
Mm. Okay, thank you. Nice presentation. Thank you.
That was nice presentation, Maulika.
Thank
Thank
you,
you.
sir.
Uh, any questions from other participants? Okay, we'll go to the next presentation. Swarnalata, are you ready?
Yes, sir, I am ready.
Please start sharing your screen.
Okay, sir. Sir, my screen is visible, sir.
Switch to presentation.
Now, sir.
It is okay. Put it on the full screen. Okay, carry on.
Good morning to all who are in the call. My name is Varnalata and my teammates are G. Bhargavi and B. Yashashwini. We are from CBIT Pradipur. And my topic is smart charging infrastructure for electrical vehicles. Nowadays, smart charging is more important for the electrical vehicles because by using smart charging, we can reduce the time because time is more precious. Today, I'm going to tell you about the awareness, abstract, and proposed methodology and advantages, and what are the results that we get by using smart charging infrastructure. Then going to, there are different types of electrified vehicles like plug-in hybrid electric vehicles, battery electric vehicles, and regular hybrid electric vehicles, and battery-assisted hybrid vehicles. For all the charging station, a major component is electric vehicle supply equipment, that is EVSE, that supplies the electric energy for recharging of electric cars and includes onboard or offboard charger based on the level of the charging employed. And the networked electric vehicle supply equipment can perform a number of series including smart grid applications also. Then coming to that of a survey is conducted by the United States of America. There is some pros and cons for driving an electric vehicle. There is some reasons for buying an electric vehicle. The main reason is concern for the environment. As we know that electric vehicle is a pollution-free vehicle. So for that concern of the environment, most of them buying an electric vehicle. The second reason is low long-term cost, and third reason is wanting cutting edge technology, and next access to carpooling, and some other reasons have to buying an electric vehicle. There are some reasons against buying an electric vehicle. The main reason is not enough charging station. As we know that in our areas there is a petrol bunk or diesel bunk in some distances, but there is no charging station in some areas. So there is not enough charging station. And one more thing is running out of charges. When the electric vehicle having running out of charge, then it may be sometimes it may get blast or sometimes it gets some accidents. And electric vehicle purchase prices is also high, and battery repair and replacement cost is high, and some other reasons that most of them against buying an electric vehicle. In the abstract, as we in this paper we discuss mainly about the pros and cons of various proposed technologies for the EV smart charging infrastructure, and we also compare different available technologies for the smart charging electric vehicle infrastructures. And in order to keep stress on the power grid to minimum, we have a bidirectional interface equipped with multi-level cascaded power converter, and we conducted some research work is also mentioned in this paper for smart charging station. Now we will discuss about the charging methodologies of electric vehicles. For every recharging station, the quality of service is measured in terms of how the fast the vehicle's battery is charged and discharged, and also based on the long term effect on the battery performance and pricing. The charging capability of a battery on standard SAE for e-vehicles is as follows, like slow charging, standard charging, and fast charging. Slow charging is a level 1 charging. It will take charging time of at most 10 hours, and standard charging is a level 2 charging. It takes at most of charging time 8 hours, and fast charging is a level 3 charging. It takes charging time of 20 to 30 minutes. Level Level 1 charging may be suitable at homes where vehicles are normally parked for 8 to 10 hours during night through many of the electrical circuits near parking supply up to 120 volts, a rate that is only required for level 1 charging. Level 1 charging is considered to be suitable at home garages. Electric vehicle can be easily plugged in the normal house socket as it requires normal AC supply. On the other hand, fast charging may not be installed at home garages because of its special requirements, supply equipment, and high current rating and safety measures. Level 2 electric vehicle supply equipment does operate on circuits with a capacity similar to those that run appliances such as cloth dryers and electric ovens. It is suggested that electric vehicles drivers that travel long distance on a regular basis and have high capacity batteries should use level 2 charging station. Then this is the architecture for the proposed charging station. The proposed quick charging station equipped with a multi-level power converter directly powered by a PV-based renewable DC power generation. Here the charging station, the DC transmission does not suffer from the skin effect, so we have used thinner conductors can be used with the better utilization of the conductor. And in these electric vehicles can be discharged to electric grid during peak demand hours acting as a power source. Then coming to that of we have a traditional charging stations in the previous years use only diode rectifier bridges with the capability of only one-way power transfer from grid to load. It has one more disadvantage that it will absorbing the reactive power from the grid. So for smart charging, we have used three-phase pulse width modulation rectifier topology for smart charging station and also been introduced which is capable of charging battery in the rectifier mode. That is, it transferring power to vehicle from the utility grid. This is the communication bridge among all the nodes of the systems. There have some top 5 benefits of electric cars. The main benefit is cost effective and reduced harmful gases and cheaper to maintain and reduced noise pollution and energy independent. There are some advantages by using an electric vehicles as we know that electric vehicles use only electricity to charge their battery instead of using fossil fuels like petrol and diesel, and by using these smart charging electrical vehicles it is more environmental friendly and it will require lower maintenance and it will provide a better performance compared to normal vehicles. And the results that we get by using this smart charging is like this. Here the red indicates that local energy storage system and the blue indicates that energy storage system and employing power electronics and the violet indicates that proposed approach. We have study on the proposed approach architecture have been conducted and presented the development of smart charging infrastructure. The most parameter for every primer consideration in the development of charging station and that is cost versus quality of services. The quality of services is mainly determined in terms of quality of quantity of power supply and the delay in accepting charging requests and supplying electric power to e-vehicles. And it is observed that the cost gain is 4 to 6% higher in case of conventional charging station architecture than that of the proposed architecture for smart charging infrastructure. And with the energy storage units is 4 to 5% higher on small quality of service level than that of the proposed approach. With that of we can conclude that by using smart charging infrastructure, we can reduce the time taken to recharging the electric vehicle batteries by using third generation components, example SIC and GAN, using electric vehicles as an energy storage devices facility of two-way energy flow using third generation. And high power multi-power converter becomes best suitable for quick recharging method like level 3 fast charging. Moreover, it supports greater expansion of renewable power generation resources with consumers' participation in the electricity market at better economy. Thank you.
Okay, nice presentation. So now go to your proposed
Yes,
block
sir.
diagram. Proposed block diagram.
What, sir?
Have you simulated the model, or else you taken up from the paper and you are present here?
I have not go through the model, sir. I am just aware of that only paper.
Present the paper only.
Oh,
Okay,
yes,
fine.
sir.
Okay, so that means only one thing you have to know that what is the source input capacity and what is the utility capacity. These two you must know. What is the source capacity you learned there for
Source capacity, sir.
yeah, range of source capacity.
Around 30 kWh, sir.
That is kilowatt
Hour, sir.
kilowatt hour. Okay. For utility,
Uh,
utility means electrical vehicle, a single electrical vehicle. You may can take a car or bike or anything. You may take.
okay, sir.
Hmm.
Up to 100 kilowatt hour, sir.
100. That is how it is possible. The source will be 30 kilowatt hour. The utility will be 100 kilowatt hour. Means what is the possible? How it is possible?
Depending on the vehicle, sir.
30 kilowatt means 30,000 kilowatt per hour, right?
Oh, yes, sir.
For electrical vehicle, 100 kilowatt hour means this 1 lakh hour you are telling that. Then
Sir,
how it,
depending on the vehicle battery, you can select, sir.
okay,
And
that
usage also, sir.
first of all you must know the source must be high, right?
Okay, sir.
The source must be high. It's a large quantity. Utility must be a small quantity, right?
Oh, yes.
Because if you are placing a charging station, only one electrical vehicle going to charge, or else more number of electrical vehicle going to charge in that place.
More number of, sir.
That means that capacity should be very high, na, right?
Oh, yes, sir.
Very, very high. It should be. Okay.
Okay, sir.
That only I'm asking that. Then smart charging means how you tell, simply you may tell how they are practically they are applied here.
What, sir?
Smart charging in your mobile phone also the smart charging option is there, right?
Oh, yes, sir.
How it is possible? A simple smart charging, how it is possible? Smart charging means you are mentioning the fast charging or else some other point.
Oh, slow charging, standard charging, or fast charging, sir.
That only want mentioning. Okay, for
Mm.
fast charging, how it is
Wireless,
possible?
sir. Wireless.
Wireless. Wireless means the transmission receivers also there, right?
Yes, sir.
The stations having chargers, having transmitter section are there. Then vehicles having the receiver sections have to be there, right? Then
Yes.
only you can able to transmit source to utility, right? So here the frequencies, how you can fix those frequencies here?
50 to 60 hertz, sir.
50?
Less than more than normal frequency, sir.
More than normal frequency. Other that is how much approximately you are referring on paper, na? In that paper, how they show that?
I think approximately 100 hertz, sir.
100?
Hertz.
100 hertz or 100 kilohertz?
Kilowatts, sir.
So 100 kilohertz means how you change the frequency in the section? Because the input will be a fixed, na? It's a 50 hertz frequency in Indian standard. In American standard, it will be a 60 hertz frequency.
Cycloconverters, sir. By using cycloconverters.
By using cycloconverters. So by using cycloconverters, what they are doing there? They are changing the frequencies only, right?
Yes, sir.
Then how the fast charging will be taken place here? That means in the transmitter side, the frequency range is there. Receiver side also and frequency range is there.
Oh, yes,
Okay,
sir.
it will be 1:1 or 1:2 or 1:4. How much it will be?
1:2, sir.
1:2 means it is possible. 50% you make it loss.
What, sir?
50% you make it loss in the section.
50%.
It's a transformation, no problem. But here there's telling that 150, let's say alternating to 50% means how it is. This is not depends upon the frequency. Actually, this is depends upon the ampere range. Actually, okay, you must know
Okay,
that,
sir.
aware in that ampere range is very important, because if you're giving more ampere to the utility means the fast charging will be taken places. If you're giving less ampere mean it will be a slow operating point. Understand? So
I
depends upon
understand.
the ampere only. It will be considered as a fast, medium, and slow. Okay,
Okay, sir.
this is the important factor. But you not mention this current in that full presentation. I check it out full presentation, but there is no such points there. So only I am telling this point to you, right? So
Okay.
fast charging mainly depends upon the current as well as the frequency ranges, right?
Okay. Okay, sir.
Okay, thank you. Anyway, nice presentation.
Thank you,
Thank
sir.
you. Yeah.
Okay, thank you, Swarnalata.
Thank
So,
you, sir.
we'll take a tea break now, sir, for 10 minutes. Soon after 10 minutes, we'll rejoin the session.
Okay, fine.
Sir.
Service
Thank,
time.
thank you, sir. Thank you, sir.
Mhm.
Hello, 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 mic test.
Welcome to post tea break session. So, with your permission, I would like to start with the next presentation. Yamini and team, are you ready, Nana? NCVI 020.
Yes, sir.
Okay. Please start sharing your screen.
Yes, sir. Sir, am I audible, sir?
Yes. Please carry on.
Good morning, everyone, and respected chief guest. Hope you are having a pleasant morning. Today, my name is K. Amni, and under the guidance of Mr. Narsinghulu, sir, and my colleague student Yalam Bhavani Yadav, we're going to present a presentation on smart way of electrical vehicle charging using solar energy. As we know, today the most hot topic other than sun is electric vehicles, and the power which is used for electric vehicles is electricity. As we all know, the leading energy consumption is basically in the form of electricity. There will be more extraction of raw materials for the generation of electricity. So there are two ways where we can obtain electrical energy from renewable sources and non-renewable sources. Whereas non-renewable sources are very harmful due to the harmful emissions and cause pollution for the environment. So we go for alternatives which are wind energy, solar energy, tidal, and etc. So in this concept, we're gonna learn about how we can empower our electrical vehicles through renewable resources. So as we all know, the more probably the first thing that comes to our mind when we see the term renewable is solar energy. Also, there are so many other sources which we can generate the same power as solar energy, but the difference is there will be vast, there is an abundance of solar energy because it is unlimited and it is of infinite source. So we're going to make use of it properly. And as you can see, most of the energy used is basically comes from non-renewable energy sources, which is basically thermal stations. Almost 30% of the energy we use now is from thermal power stations, but we also have to pay for the consequences. So there will be excess pollution which may affect our health and our environment, and which causes climatic changes and melting down of glaciers. Apart from this, there will be harmful health conditions, and there are also high costs. Other than there will be high running costs and maintenance costs. So we go for alternatives which are solar and wind. As for now, let's go for a brief discussion about wind energy. Due to uneven heating of Earth, there will be the production of wind that travels from one altitude to another altitude. So when we make the use of this wind, we can generate electricity. There will be wind pressures basically mainly in coastal areas and hilly areas. So when we make use of this, we will be able to generate electricity. But the only problem is there will be high initial cost, and also there will be less amount of energy that would be generated from this wind energy. As we can see, the energy that is generated from wind turbines is basically AC and is also of low quantity. So we give to a converter which is a rectifier which converts AC to DC, and also before we transmit the energy, we would likely to step up the acquired energy to a certain level to reduce transmission losses, and also we use HVDC transmission, and at the receiver station we may use a DC to AC converter, which is basically an inverter, so that we can acquire much more power from basically a small wind turbine. And the acquired turbine and the acquired energy will be given to the charging station where we can charge our electrical vehicles. So thus we can charge the electrical vehicles without any pollution and in a clean manner. And since there is a disadvantage of wind, that is it is not available continuously, and also we have to rely on so many equipment for the conversion of the process, and also there is a long distance between the source and the end use. So we go for solar energy. As we all know, the sun, which is the primary light source on Earth, is emitting the solar radiation, which is basically a form of heat. As we all know, energy conservation principle, which mainly explains that energy is neither created nor destroyed, merely converted from one form to another form. Here also we would like to convert the solar energy, which is solar radiation, into electricity by use of PV cells, which are photovoltaic cells. So by using photovoltaic cells in the combination of series and also in the form of panels, a group of cells connected in modules and packed tightly so that they can form modules, and they are called panels. By using of these panels, we will make use of the solar radiation into electricity, and this electricity is basically DC, so which we can either use the DC to charge the vehicle, or we can store the acquired energy to a battery. In that form, we can use the acquired energy in both ways. Also, if there is any as this problem of the solar panel is, it is mainly fixed, right? So we might use a concept called MPPT, maximum power point tracking system, which basically involves the tilting of solar panels in the direction perpendicular to solar radiation, which gives us maximum power. So by using this concept, we may acquire maximum power from the solar energy. As we can see, there is also disadvantages of solar energy because there won't be the same intensity of solar radiation in every season. So typically in winter it is 10 kilowatt hour per day, and spring it will be 30 kilowatt hour per day, while in summer, which is right now, but basically not today, so it will be 50 kilowatt hour per day. So I might go for combining these two renewable resources. I mean, there will be combination of resources, but the most available combination is wind energy and solar energy. So by combining these two power sources, we can acquire basically the advantages of both sources. So as you can see, the curves imply that the amount of power acquired from wind energy and solar energy, and also the average power that is combinedly from both sources. And as for the ways of charging the electrical vehicle from charging from solar energy or renewable energy sources, we might go for various ways. For example, here from solar panel, we can directly charge the vehicle, or we can store it in the form of battery. In this slide, there is a way that if there is not availability of solar energy, I mean, if there is a small intensity of sun, we might use the stored energy of battery to power up the vehicle instead of relying upon the grid. And in here, if you have an excess solar energy power, so we can send back to grid and acquire some money, or we can use it for a house purposes also. And also here we can also use a two-way converter, like we can both send power to and off from the grid. So that's it for now. Thank you for giving us this opportunity.
Yeah, many nice presentation. So, have you done any simulation model or else presenting a paper?
I have presented my paper, sir.
Not simulate any model, right?
No, sir.
Right. Okay. Okay. Have you have an idea of what SOC?
SOC, sir.
Yes.
Single point of contact.
Yes. SOC means not single point of contact. SOC.
I don't know,
State
sir.
of charge. SOC is
State of,
nothing
sir?
but state of charge.
Okay, sir.
State of charge, because while charging a electrical vehicle, okay, from that EV station you're going to charge means there is a battery, right? Practically
Yes,
there is a
sir.
battery. In electrical vehicle
Yes,
also
sir.
there is a battery, right? So it
Yes,
depends
sir.
upon the state of charge of the vehicle,
Yes,
whether
sir.
whether the vehicle need energy or not. Likewise we can decide. Okay,
Yes, sir.
likewise
Yes, sir. Yes, I get it now, sir.
depends upon the state of charge of the station. They can able to send, they can able to supply or else not able to supply. Likewise, a point will be there, because now you are going for hybrid section, right? So
Yes,
hybrid
sir.
section, if you're going for hybrid section means how you maintaining the battery of that station. Okay, that is BSP, bulk storage capacity, right? That BSP have
Yes,
to be
sir.
maintained there. The state of charge will be how it is maintained. Those things you have to discuss clearly in the section, right? You have to aware
Okay,
in
sir.
that condition. Okay.
Yes, sir.
If you better you simulate a model regarding this means you will get more idea in regarding this one, right? Okay,
Okay, sir.
anyway, your presentation is well, giving a good topic to share among us, right? Okay, right,
Thank you,
fine.
sir.
Right,
Thank you, sir.
okay. Well, Saik Mosa, next presentation.
So, any more questions from the participants? Any questions from the participants? Okay, we'll move to the next presentation. So NCVI 013, Padma Likita and team.
Okay, sir.
So are you online?
Yes, sir. We are online.
Please share your presentation.
Yes, sir.
So next presentation will be Sainath and team. Sainath, are you online?
Yes, sir.
Okay. So wait to complete for this presentation, and soon after this, your presentation will be there.
Okay, sir.
Okay. Please share your screen, Nana.
Just a second, sir. Good morning, sir.
Good morning.
My name is Nagama Likita, and I'm currently pursuing my graduation in.
Ma, put your presentation on full screen, Nana.
Okay, sir. My name is Nagabadma Likita, and I'm currently pursuing my graduation in the stream of Electrical and Electronics from Chaitanya Bharati Institute of Technology. Me and my friends had done a paper called Electric Vehicle Smart Charging, and in this, the main next slide. I'm going to say the intro of the electric vehicles, and in addition to charging and charging plugs, and up to the electrical vehicle future. And there are two types of electric. Then there are two types of vehicles, namely gas and electric type. In gas, we use a combustion motor to burn the gas and to ignite the gas, and the vehicle is run with the use of a fuel called gas. And in hybrid, uh, in gas uh, in gas vehicle we don't use a battery, but in a hybrid it is used for the short distances, and it adds the battery along with the electric motor. And compared to the gas vehicle, the efficiency is also more in hybrid. And in coming to the next second vehicle type, that is called electric, there are again two types: plug-in hybrid and electric. In plug-in hybrid, in plug-in hybrid, a large battery is used when compared to the hybrid, and it is used for only medium distances, but it is more efficient compared to the hybrid. And in this plug-in hybrid, we use electricity and gas as a fuel. But in electric, it is used with the largest batteries, and it is designed with electric motor, and it is used for the long distances compared to the plug-in hybrid and hybrid. And it requires high torque at the stage of a starting. No gas engine is required. And coming to charging, there we use two types of charging cables. That is what mode 1, mode 2, mode 3 charging cables. In mode 2 charging cables, it is directly connected. It is used in home appliances with the single phase voltage, that is what called 220 volts with 50 Hz frequencies. But in mode 3 charging cables, it is used in the charging stations. Mode 3 charging cable is a connector cable between the charging station and the electric car. In Europe, the Type 2 plug has been set as a standard to allow electric cars to be charged using Type 1 and Type 2 plugs. Charging stations are usually equipped with Type 2 charging socket. To charge our electric car, we require either a mode 3 charging cable from Type 2 to Type 2, or a mode 3 charging cable from Type 2 to Type 1. And coming to charging plugs, there are two types of charging plugs: Type 1 charging plug and Type 2 charging plug. The Type 1 charging plug is a single phase plug which allows for charging power levels up to 7.4 kilovolts with 230 volts voltage and 32 amperes current rating. The standard is mainly used in car models from the Asian region. Very few public type 1 charging stations are used in our India. And coming to type 2 plug, the triple phase plug main area of distribution in Europe is considered to be the standard model. In private spaces, charging power levels up to 22 kilowatts are common, while charging power levels up to 43 kilowatts with 400 volts voltage and 63 amperes AC can be used at public charging stations. And all electric vehicles can use a level 1 charging, but now the only Tesla which is designed by the Elon Musk uses only the level 2 charging plugs, and the charging plugs which are designed for Tesla can be only used for Tesla car itself, but cannot be used for the other cars. And the charging cables, because it is designed with a it is specified and designed for the specific voltages and current ratings and power ratings. So the charging cables cannot be used for which is designed for one car cannot be used for the another cars. Many DC charge stations have the CCS and CAD-MO plugs. CAD-MO plugs is a quick charging system, was developed firstly in Japan and allows charging capacities up to 50 kilowatts at the appropriate public charging stations. These CAD-MO plug chargers mainly uses a Tesla, Subaru, Honda, etc. and Toyota. See, if the charging in our car is reducing, then we will get the sense from the sensors which is located on the top of our car or backside of our car. Senses to us to charge our car immediately, and these are designed. These sensors are working through the websites, apps, and trip planners. While when we install the app in our mobile or in our car, this app senses us to charge immediately. And now my friend Tanuja will continue this. Tanuja, please carry on.
Coming to the benefits of electrical vehicles, there are few points that we will consider under the electrical vehicle benefits. Those are charge faster, charge safer, and monitor your electricity consumption. Coming to charge faster, smart charger devices enable the safe usage of maximal charging power. This makes charging much faster compared to using traditional power sockets. And coming to the charge safer, smart charger is significantly safer because smart devices automatically test the connection between the car and the device before starting the charging event. That's why we can say there are more benefits when compared to the fuel vehicles and compared to the electrical vehicles. And now coming to the monitor your electricity consumption. Neighborly disputes about your increased electricity consumption can be solved by connecting the charge devices to the charging services, which automatically collects the consumption data. This way charging costs get charged directly from the electrical vehicle owner to help the user which company costs. That service can be reported to the cost of both public and home charging automatically to the employer. Electrical charge with a renewable. Coming to another benefits to the to the electrical vehicle, there is the optimized charging time. We can charge the vehicle within an optimized time, which smart charging timing can be optimized based on the price of the local electricity market, like not pool spot. This saves money and also benefits the environmental and the electricity grid. As the prices follow electricity demand with charging time optimization, electrical vehicle charging balances the supply and the demand of electricity and lower the need of electricity generations. These are the benefits of the electrical vehicle. And coming to the public charge locations, by using the sensors in the electrical vehicle, we can sense the charging locations, which we can move further with our charging by charging the electrical vehicle. By using the sensors, we easily find the location of the electrical charging station. Now coming to the near future of electrical vehicles, we should at present electrical vehicles are not in much demand in our country. In our country, by creating awareness in the society, we can increase the sales of the electrical vehicles. And in India, there is no much there is much checking test to the batteries and things we are used in the electrical vehicles. We should make awareness, and we should implement a proper stations to create awareness and encourage the people to use electrical vehicles. We should install the more charging stations, more charging stations. That's it from our side. And there is any questions from your side?
Nice presentation, Tanuja. Okay, go to the emission page. Emission page, yeah.
Sir, can you please come back, sir?
Emission, not here. Please go forward 3 pages. There is no page numbers. One more page.
Benefits, sir?
Wait. This one.
Yeah, okay.
This one. Here, what is CO2, E, NOx, and PM?
That is carbon dioxide, sir. Nitrogen oxide.
Okay, what is PM?
Sir?
What is PM emission?
Primary emissions.
Primary emission. Carbon dioxide is a gas, nitrogen also and gas. What is PM?
Sir, can you please give me a minute?
Because he's showing that
particulate matter, sir.
Particulate matter means, can you explain that? What about particulate matter? Because
it is used to describe solid particles and liquid droplets.
Okay, it is for gas line vehicle, it is 1.4. Then for EV on grid, it will be 1.1. For renewable, it will be 0.3. Yes, that only I mentioned that. So here, how this value is reducing? That's my question. Because you are not simulate any simulation, just you copy it and paper and show here, right?
No, sir.
You made a simulation for this?
Sir, what, sir?
You design any simulation model for this?
No, sir.
Yeah, sir. Just you present a paper from outside, right? That's all, right? Any of the journal. That only show only. So only I am asking this one. So this PM point of view,
okay,
how it will be? How you can explain this PM? That is a particulate matter. This type of emission is well found in which
sir,
which section?
I'm not audible your voice, sir. Can you please come again?
This PM emission is occur in which place actually?
In our surroundings only, sir.
Not in that. Already you have taken only answer to me. So even the non-combustible
Engine, sir.
sections are gonna
Engine. Engine.
yeah, now only you catch the point. Inside the engine, there is a non-combustible fuel. Something is there. Okay, that type of emissions will be in
Yeah.
more in the
Yes, sir.
gasoline. Okay, if it's a PHEV means it will be compared to that gasoline, it is somewhat minimized. Okay, but if you go for renewable,
Okay.
there is no engines are there. There is motors only we are
Yes, sir.
using, right? Motors only we are using. So maximum the type of emission will be very, very less. So only it will be given as a 0.3 IBS. Okay.
Okay, sir.
Okay, thank you. Nice presentation. Shall we move for next presentation? Thank you.
Thank you, sir. Thank
So,
you so
any
much.
more questions from other participants? Any more questions? You have a question. Any more? Okay, we'll move to the next presentation. Presentation by Sainath and team. Sainath, are you ready?
Yes, sir.
Please share your screen now.
Good afternoon, all. This is Sainath and my co-author, sir, P. Nandavardhan Reddy and P. Sai Deepak. Today we are going to give the seminar, give the seminar about drawbacks and overcome techniques on electrical vehicles. Why we have chosen this topic is we have to know the what are the drawbacks and give the solution about these electrical vehicles. So we are done a job with this topic. So when we move to the abstract, we will see the what type of drawbacks and what are the overcome techniques in our seminar. And when we move to the next slide, the introduction. What is an electrical vehicle? Electrical vehicle is an automotive vehicle that uses on one more electrical motors per population. It can be powered by a collector system with electricity from extra vehicle sources, or it can be powered autonomously by a battery, sometimes charged by solar panels or by converting fuel to electricity using fuel cells or generator. In this figure, we can
Sainath,
see the manufacturer. Sir,
sorry to interrupt you. Please ask other devices to put in mute. If
okay,
any of
sir.
the other devices are with you, please ask them to put in the mute.
Okay, sir.
Carry on.
Right, we thank you, sir. Right, we are able to see the manufacturing of the electrical vehicles. So many factories are able to manufacture this type of electrical vehicles. And this electrical vehicle we are using in day-to-day life. And when we see this is the one model of the electrical vehicle, and when due to the drawbacks of EVs, finding a charging station, EV charging station, fewer and further distances than gas filling station like petrol. And second point is charging takes longer time. And third point is the driving range on a full charge. And next we move to the next point, higher initial purchase cost. And the last point of this drawback is replacing the batteries is more expensive in this EV vehicle. And when we go to the overcome techniques, first perceived cost. This means EV vehicles are some are higher prices, same size model. When we want to get this vehicle with low price, we have to study what is the EV vehicle, what we can do to get this EV vehicles with less cost. And when we go to study the parts of the EV vehicles, we can know how we can purchase the uh, cost of the EV vehicle. And when we move to the range anxiety, this is when we in driving the cars and charging. This is range means we can say that this is one kind of speed, and this is in New Zealand there is a practical one. Over 90% of the daily vehicle is 90 kilometers or less, well within the range of an EV. It can help remind the team they will still have the option of driving an ICE vehicle if it's really required for extra long driving distance. This means we can able to uh, go 90 kilometers or less in their daily life with the 90% charge. And when we move to the next slide, driver education. One of the most important point is driver education. Then we can say that this driver education. That means we can learn the how to operate this EV vehicle. Then we can easily drive this EV vehicle. Then we can use this EV vehicle longer time also. With this education, we can do we can use this EV vehicle for longer time. Learn about the next point is learn about EV performance and fit for purpose. EV in corner who can choose the right EV for your company. That's where we come in. We can help your fleet sold with this best EVs for your needs and your budget. There are already EV options with greater power performance for the majority of the New Zealand field requirements and for the most specified need, new models on the way. For example, a common objection we hear there is no EV for load carrying and more heavy duty. This is true for now. We can say that there is no heavy vehicles on EVs like we can say on fossil fuel vehicles like lorries, containers. These like vehicles we will not see in electrical vehicles and range and charging speed. This is for the biggest determinant to make EV buying decision. We can choose to buy the EV vehicle. We can say how much charging capacity and how can it will its work time. EV's buying decision is the driving range, its premises, and more than that, it is the fact that reloading the electric car's batteries to full takes much more time than filling up a fuel tank. This means we can say that uh, less time we can take before filling the fuel tank. Compared to the traditional petrol station, charging stations are harder to find. Normally, limited investment costs and difficult infrastructure development. The cost of installation is from $2,500 for a slower charge to $35,800 for fast charging plus. Nationship fees such as permits and regulations have made charging stations an expensive investment, further enabling people to charge where they usually park at home or work at work has its own challenges, such as dealing with multi-tenant buildings, grid connection management, and charging slot availability. This results in a smaller network of functional charging stations and have deterred consumers for making switch to EVs. In this figure, we see the good charging technique of a EV vehicle. That means uh, nowadays we can see for electrical vehicles in our country, in sunlight we are placing the charging. This means we have to build this like shelter from the EV vehicle, and when we provide like this charging arrangement, we can use smoothly the EV vehicles. Smart and flexible charging. Cars are usually idle 90% of the time. Smart and flexible charging technology utilizes unused power from car batteries to provide additional electricity supply to the grid during times of peak demand or in some cases just intelligent pauses for reducing charging power. Conversely, it enables consumers to recharge during off-peak hours at one-third or less peak hour charging price, thus reducing grid congestion during peak hours and cost consumers by allowing EV owners to schedule charging based on power, conscience, price, and priority, and to sell unused power back to the grid. The charging system can better anticipate sudden peaks in electricity demand. The technology also enables the grid to increase capacity, serve the increased demand from electric vehicles at a lower cost to consumers, reduce the grid system stress, and avoid energy price suggestions. And when we go to the next slide, we can see the establishing of EV charge stations. This is the big challenge in our country, and government provides certain guidelines to establish these EV charging stations. Government guidelines are the government of India has made it compulsory set up an EV charging station for every 3 kilometers in cities, every 25 kilometers on the highways, and 100 kilometers on the highways for heavy duty vehicles. Now we can see in certain position, some of the private companies established EV charging stations like Hyundai, Kia in our country. And when we move to the conclusion part, when we when we go next 10 years, there is no fossil fuel vehicles because fossil fuels are renewable energy sources. So they are not producible. In next future generation, we can use only electrical vehicles and we can reduce the fossil fuel vehicles. And next to this world, we can see with EV vehicles that we represent in this figure like EV Tunia, all electrical vehicles. Thank you, sir.
Nice presentation, Nandavara Reddy. Actually, you are give a good points to our listeners. Okay, but one thing here, the right place to fit a EV station, that is which is important, very important.
Yes,
How
sir.
to adapt this one in the network, that is very important, right?
Yes, sir.
For this purpose, many papers are there. Okay,
Yes, sir.
so you can test with that, then you can apply, and then real-time test systems are also there. So you can apply with that, then you can simulate over the simulation. Then from that you can getting idea of where the proper location, then what are the impacts that found in the grid section. Everything you can discuss means it is very good for you and others, right?
Yes, sir.
Okay, it's anyway such a nice presentation you are delivering here. It is I think helpful to others. Thank you.
Yes. Thank you, sir.
Stop sharing your screen, Sainath.
Yes, sir.
We'll move to the next presentation. Presentation by Girish Sai. Girish Sai, are you ready? Girish
Yes,
Sai,
sir. Yes, sir. Yes, sir. I'm ready, sir.
please start sharing your screen.
Yes, sir. Yes, sir. Good afternoon, everyone. Myself, Girish Sai. Our presentation today is about recent development of electrical vehicles.
Good afternoon.
Good afternoon, sir. Coming to abstract, this paper provides an overview of the recent works of the electric vehicle in the region. The paper describes the development and the comparison of different parts of components. The major components in the battery technology, charger design, motor, steering, and braking are examined. The paper finally shows some electric vehicle prototype as a conclusion of the papers. And coming to the introduction, electric vehicle is nothing but a vehicle which uses the electric motor for the propulsion or movement. Since the fossil fuels are exhausting nowadays, there is a greater need to get an alternative. One such alternative is electric vehicle in place of vehicles that uses the internal combustion engines. And coming to electric vehicles and hybrid electrical vehicles comparison, some variations of electric vehicle are completely pure electric vehicles, and some are hybrid vehicles. Hybrid electric vehicles uses a IC engines in parallel with the motor so that it can run on fuel and electrical energy, whereas pure electrical vehicle completely depend upon the electrical energy. Using hybrid vehicle, it allows the electric power can be obtained from the engine. The figure shows the different different paths of different parallel path of hybrid electric vehicle system. And coming to the key points, key components in the electric vehicle, the battery charger, battery, inverter, motor, and different types of different components in this system. The battery charger takes it takes AC power from an electrical outlet, and it converts into DC power, and then it uses then it and it uses it to charge the battery pack. Running in vehicle, DC power is drawn from battery and it is converted into AC power using an inverter. This AC power drives the electric motor. And some additional onboard onboard components also be driven using battery backup. And coming to the motor, which type of motor is used in this system? Generally, the motor is the major part of the electric vehicle. These are the different types of motors used for this electric vehicle. Mainly DC motors, induction motors, and DC brushless motors are what we use for electric vehicle. And coming to direct drive and in-wheel motor, the motor can be installed mainly in two ways. That is direct drive and in-wheel motor type. In this method, in direct drive method, the motor is directly connected to the driving wheel system. And the second one is in-wheel motor type. It is a proposed method type. In this system, the windings are placed on the wheel rim and tire. This method eliminates the gear system. And since each wheel acts as an independent motor, the vehicle operates in four-wheel drive system, four-drive mode, and each motor can run at independent speeds, and anti-lock braking system can be implemented easily by using this technology. And coming to energy storage, the battery is the main energy storage in the electric vehicle. Since the motors are the driving sources of the electric vehicle, various types of batteries are being developed to improve the capacity to weight ratio, charging time. Currently, traditional lithium-ion batteries are being used. A technology of crystal structure batteries that require much less charging time has been proposed. Other alternative is to use an ultra capacitor, but due to the heavy weight, it is not being practically used. Coming to charging systems, for the electric vehicle consists of a controlled rectifier circuit which converts the AC power to the DC power for charging the batteries. Research has been made to develop charging systems that to handle the high power and charge the vehicle in less time. And as a conclusion, this paper discusses the recent development in the electric vehicle. The paper first describes general structure and discusses the energy storage. It then extends to the future vehicle components. The paper provides an overview of the recent electric vehicle work in the region. Thank you, sir.
Nice presentation, Kiran. Actually, here a new topic incorporated here, na? That
Yes,
wheel in motor, right?
Yes, sir.
In-wheel motor.
Yes, sir. Yes, sir.
What type of motor is used preferred here for in-wheel motor?
In-wheel motor.
Because already you given three types of motor: AC motor, DC, and BLDC, right? So in-wheel motor, what type there? What here? Which one is provided here? Which one is preferred here?
Generally, it is proposed method, sir. Research has been taken.
Okay, proposed method only. The motor you tell na in-wheel motor means
Sir, inbuilt motor means is nothing but the arrangement of the armature of a motor is in rim, sir.
Yeah, that I understood.
It's the main
That I
advantage of
understood.
this.
That I understood. I am telling that any name for that special, it is coming under special machines now. So
Yes, sir.
only I am telling that special machine. What is the name?
Sir, I don't have awareness of this, but
Go to that machine. That is a switched reluctance motor. See there.
okay,
SRM.
sir. Thanks.
Yes, it is SRM type motor. Okay.
Okay,
Okay.
sir.
Next one, another one point here. Go to slide number 5.
Okay, sir. Yes, sir.
Here, there is two types. So one will be inverter circuit. That is for motor you're going to send a supply, right?
Yes, sir.
And that is motor means here you are using an inverter here.
Sir, the inverter is a device which converts the AC into DC, sir. In this place of motor, we are using induction motors, sir. I mean AC motors. Then we have used the inverter, sir. Otherwise, no need of it.
Induction motors are preferred.
According to AC, induction motors is used.
Induction motors are because induction basically. Okay, wait. Induction motors are basically having less torque na compared to DC machines,
sir.
right?
Yes,
Then how it is preferred here?
No.
Because of some. Yes, sir. Because some various speed are achieved, sir, by using
Various
induction
speeds,
motor. In AC motor, we can use it single type AC machines also.
I think you have taken this paper from very old paper. I think, right?
Yes, sir.
That only the problem. Okay, no problem. Go with the new reference paper. It's helpful for you. Okay, because only now finally they dictated two types of motor is suitable for EV station. One is BLDC, another one is SRM. BLDC is two hurdles to that. Okay, this cost wise, then technical wise, everything SRM is better. Recent days mostly they are preferring industry section and customer section. Everyone are preferring that SRM type machines only, right?
Okay, sir.
Thank you. Nice presentation anyway.
Okay, sir.
Right.
Thank you, sir.
Thank you, sir.
Okay, sir.
So next presentation is by Gaussian team. Madam, are you ready?
I can manage it.
Kiran, please put your mic off. Gausia madam, are you online? Gausia madam and team. Anyone? Nagarjuna? Veernaran Reddy? Gausia. Madam, please unmute yourself. Any issues from your side, madam? So next presentation will be by Vamshi Kalyan and team. Are you ready, Vamshi Kalyan and team?
Sir, ready, sir.
So, get ready with your presentation, and soon after Gausha's presentation, your presentation will be there.
Okay, sir.
We'll take 2 more minutes for Gausia. If not, you start your presentation.
Okay, sir.
Sorry, sir. Due to some technical issues, so one of the present is unable to present her presentation. We'll just give 2 minutes to her, sir.
I think she left. I think Sai Kumar sir. Gausia, I think name.
Okay, we'll start with Vamshi Kalyan's presentation, sir. Vamshi Kalyan, please start your presentation.
Yeah, go ahead. Vamsi.
You're there, Vamshi.
Yes, sir.
So please share your screen. Vamshi Kalyan. Switch to the presentation. Put it on full screen. Press Shift F5. Press Shift F5. Or else click on the slideshow icon at the bottom. Right side bottom. Slideshow screen. No. Go to the presentation. No. Go to the presentation, Nana. Click on the presentation. No, not this. Go to the presentation, Kalyan. Please speak up, Vamshi Kalyan. Is everything okay from your side? No, don't click on stop sharing.
Yes, sir. Ready, sir.
Okay. Now put the screen.
Okay, sir. Okay, sir.
Okay. Put the presentation on full screen. Don't switch the tab, Nana. Go to presentation only. Go to presentation. Go back to presentation.
Any one of the batchmates near to him, just guide him to.
The other batchmates, Nana, please guide Vamshi Kalyan. Go to presentation. Just press Alt tab. Alt tab. Gosha madam, is your team ready?
Sir, there is a technical issue with Gausha Madam team, sir.
Sudarshan, are you there? Sir, 2 more minutes, sir.
Yeah. How many batches still more than morning schedule?
So only 2 left, sir. 2 presentations left in forenoon session, sir.
This Vamsi Kalyan and Go 65.
Yes, sir. Only 2 left. In the afternoon, we have 5 to 6 presentations, sir.
Okay, okay.
So will you be there in the afternoon session also, sir, or Stanley sir will join?
Stanley sir only, I think. He told me today morning only, I think.
Okay, okay, okay. So you will be joining in the bilateral section, sir?
Yeah, sure. I will. What time it will be?
Sir, around 3:30 or so, sir. Before that, we'll inform you, sir.
Okay,
Through
no problem.
Dr. R. Sarvanan, sir.
Okay, fine. Yeah. Thank you.
Okay, sir. So Vamshi Kalyan. ఏంది బాబు వాళ్ళకు స్క్రీన్ షేర్ చేయడం కూడా రావట్లేదు గౌసే ఇస్తాను Okay, now you may present, madam. Unmute yourself. The unmute yourself. Sir, Veerna? Unmute yourself and speak. Right corner, you can see. No.
Before share the presentation, you unmute and then you can share. It is easy, I think.
No. Okay. Cam kuda ani. Cam and Now it is audible, Veerna. Please share your screen. Cam.
Hello, sir. Aslam, sir.
Sir, please kindly.
It's audible. Just to share your screen. That's enough. Yeah.
My voice audible for you, sir?
Yes, it is audible,
It's
sir.
audible.
Please share your screen.
Confirm. Madam, screen share కావట్లేదా? కట్ చేసి
Madam, is it
Aslam
possible
sir,
to you?
there is technical issue, sir. Vina and sir will say in the afternoon, sir.
Okay, madam. Okay, madam. So we'll call for the session, sir. Now, with your request, we are going to close the session. And almost 9 presentees has presented their presentation.
Okay, sure.
Thankful to
Carry
all
on.
presentees who has given presentations, and thank you to you, sir, as well, for gracing this forenoon session and having here giving inputs and suggestions to the presentees.
Sure. Thank you. Thank you so much.
Thank you so much, sir.
Mm.
So post session will be joining at 2 p.m. So participants are requested to join at 2 p.m. sharp.
Okay.
Sir.
Thank you. Thank you so much, sir. We went.
Thank you so much, sir.
Right. Fine.
Have a good day.
You have a good day.